Hello guys, I would like to launch in my channel, Math Coefficients and Terms, a series of videos highlighting math common errors, MCE, which I have observed through my journey of teaching 35 years of mathematics. Now, there are 4 parts I would like to upload within few days maybe. Part 1, which I'm doing now, it will deal with the MCE in radicals and real numbers. Part 2, it will deal with MCE in exponents. Part 3, it will deal with the errors in factoring equations and inequalities. And then part 4 will deal with MCE in general topics like fractions, complex numbers, expressions, and order of operations. And there are other videos that might come later with some errors. So this is part 1. In part 1, I will present 7 MCEs, 7 math common errors, and then I will tell you the correct version of that. Also, I would like to share with you 4 questions with complete and detailed solution to avoid these errors, and I will leave for you at the end 3 practice questions with answers only. Let's start part 1. The first common error I have observed, many students, when they have square root of a squared plus b squared, they write a plus b. Big mistake. Because radicals, we cannot split the radicals and distribute them in the case of addition or subtraction. So I put here a big error in red. This is an example for this mistake. Square root of 3 squared plus 4 squared. You cannot write 3 plus 4 is equal 7. Rather, you have to square the 3, you get 9. Square the 4, you get 16. You add, and then you can take the square root if you can. If you have here a number that you cannot take a square root, like square root of, let's say 19, square root of 21, leave it. Now, square root of 25 is only 5. That's the first error you can learn. You can pause anytime, you can write some notes or something. Let's see second one. Similar idea, but if you have a square root of a plus b, only just any numbers, perfect square or not perfect, you cannot also split or distribute the radicals like this. So square root of a plus b not equal to square root of a plus square root of b. The first one here is an example which is wrong. If you have square root of 36 plus 25 under the radical, you cannot have square root of 36 plus square root of 25. Many students will do this. 6 plus 5 is 11. That's wrong answer. Rather, you have to add inside. 36 plus 25 is square root of 61. You cannot simplify it. Just leave it. Let's go to the error number 3. If you have square root of x squared, somebody say this is equal to x. That's wrong. The correct answer, square root of x squared, should be absolute value of x, because square roots cannot be negative. If you write here x, look at this example down here. If you write x, it looks nice, but it's wrong. If you write x, maybe we have square root of minus 5 squared. So the x here is minus 5. That's the x. If you write only minus 5 on this side, on the right side, that's wrong. So that's why you have to put always an absolute value on the square root to make sure that the answer is positive. Square root of 81, only 9. So if you see something like this, square root of a squared equals a, that's wrong. You should write square root of a squared is equal absolute value of a. That's error number 3. Let's see number 4. Very similar. If you have square root of x squared is equal minus x, that's also wrong. As I mentioned in number 3, the correct answer, square root of x squared is the absolute value of the x. So this is an example here, square root of minus 3 squared, you should put an absolute value. If you put only the minus x, it's not correct, because x can be positive, can be negative. This is the correct one, absolute value only of the k. Okay, let's see now, another common error I have observed. If you have something like square root of 36, many students will say plus or minus 6. That's completely wrong. The correct answer, only plus 6. Square roots cannot be negative. So if you have a square root of minus 8 all squared, just 8. Square root of 49, sorry, just 7. This one here, square root of b squared, you cannot write plus or minus b. Square root of 49, you cannot write plus or minus 7. Now let's go to number 6. A little tricky. When you have two radicals inside each other, just be careful here, please. Let's go to the correct first. It's easier to understand. If you have here two radicals, mth root of nth root of x. So the first index here is m, and the second index is n. And here you have to multiply the indices. So mnth root of x. This is the correct formula. Now look here, suppose we have cube root of x squared, or a little back, cube root of x squared, square root of x. We cannot multiply here the index 3 with the index 2. We cannot multiply 6th root of x cubed. That's wrong. Because the formula says there is nothing between the radicals. Then you can multiply the indices. So I said the error here that you cannot multiply the indices if there is a number between the two radicals. So this one is wrong. This one, 5th root y, 6th root of y, this is wrong. This is wrong. So let's go to this number 6 here. I will show you the solution of this one here. Cube root of x squared, square root of x. I will show you how to do it. See question number 4 in the solution in this video. Question number 4. I will show you how to do the error here in number 6, which is really a nice question. You can try it before you see the solution. Just pause the video and try it, please. Now, error number 7 about real numbers. Very common, very common. If you ask a student, pi is equal to 22/7, true or false? Probably they will say, most of them, true. But it is not true. Pi equals 22/7 is wrong. So what is the correct answer? Pi is approximately 22/7. Which one is bigger? Can you figure out which one is bigger, pi or 22/7? Now, why this is wrong? I'll show you here why this is wrong. Pi is an irrational number. 22/7 is a rational number. And rational number cannot be by all means equal to rational number. Irrational cannot be equal to rational number. Now, if you want to see more about rational numbers, irrational numbers, and details, definitions, you can see another video for me on rational and irrational numbers, on real numbers in general. Now, we know pi, 3.14159, it's not ending here. If you divide 22 over 7, just normal division, or you can use the calculator, 3.1428, etc. See, clearly we can see pi is less. So 22 over 7 is little bigger than pi, but they are approximately equal because there are 3.14. Okay. Now these are some correct formulas. Some correct formulas. Okay, look at number 1 here. We have square root of a times b. Yes, we can split it here. Square root of a times square root of b. But remember, there is condition. A and b should be positive numbers. Square root of a squared times b squared. You can split it. Square root of a squared times square root of b squared, which is a times b. Condition here. A and b should be positive numbers. These are some examples you can really see. Another correct formula is 1, 2, 3, 4. Also, when you have radical of a division of two numbers. So radicals can be distributed in the case of division and can be distributed in the case of multiplication. Let's see question number 1. Find the value of the expression. Oh, nice question here. It's a good idea if you pause a little here and then try it. Square root of 9 plus 4 plus 11 all divided by square root of minus 10 squared plus square root of 16. It's not difficult. Simple number, simple fraction. Just try. The important thing here, try to avoid the errors. If you avoid the errors, you'll be in good shape. Now, solution here, just one slide, maybe a few lines. Avoid the common errors, number 1, number 2, and number 5. So, here we can add 9 plus 4 plus 11. So that's 24. Just add inside. You cannot split it because we have pluses. Square root of 24 will be 4 times 6 inside the radical here. So we cannot simplify 24. So we say 4 times 6. We take 2 out. So 2 square root of 6. Here we have square root of minus 10 squared. We cannot write minus 10, remember. Because we have to write absolute value of 10 or absolute value of minus 10. Both are correct, which is 10. Because if you simplify this, minus 10 squared, that's 100. Square root of 100 is 10. Square root of 16 is 4. 10 plus 4, that's 14. Divide by 2, square root of 6 over 7 is the correct answer. Now let's go. Question number 2. Really nice question to try before you see the answer. You have cube root, and inside you have a subtraction of 2 square roots, radicals, times big cube root, and then you have a sum of 2 square roots. Evaluate the expression. Find the value, the number equals to this expression. What do you think we can do? Since we have multiplication, we can multiply the big radicals. See the index 3 cube root, just make one big cube root like umbrella and then multiply inside the radicals. Okay. So here we have the same index, so we can multiply inside. You see this one here? Just multiply inside. Or we can use a formula here. Square root of 33, this is like A, minus square root of 6, this is like B. And then you have same number here, A plus B. We have a formula here, difference between two squares. So you can square the first one, which is 33, minus square the second one, according to the formula here. 33 minus 6 is 27. Cube root of 27 is only 3. So the whole answer is 3. The question looks difficult, but now it's easy by the answer. Question number 3, little tricky, please. Simplify the expression. How can we simplify this? Try to avoid the mistakes we have mentioned. we have one big square root, x squared inside minus 20x plus 100. Can we say x plus 10? Think. Can we say x minus whatever, 10x plus 10? Try to think, please, before you see the answer. Try to avoid the errors that we have mentioned here. This is a tricky question. Now, be careful. This is completely wrong here. If you think that you can split the radicals, minus split the radicals, minus split the radicals, this is completely wrong. So the correct steps are, make all this as quantity squared. So x minus 10 all squared. So this is like a number here, like a number m or n or y or k or something, all squared. So we use the correct formula. This one squared, it will be an absolute value of x minus 10. So this should be absolute value. If you don't write absolute value here, this is wrong. Because if you don't write absolute value, if you write only x minus 10, why it's wrong? Because x minus 10 can be positive number, can be negative number. X is variable. You have to mention, you have to write absolute value of x minus 10 to make sure that the answer is positive. Let's go to the nice question. Cube root of x squared times square root of x. Now, what is the mistake that students can do here? They multiply the indices, that's wrong. Now, because we have the x squared here inside, see, this is the problem here. If we don't have x squared, yes, you can multiply the indices. Since we have x squared, let me show you the correct steps. Or you can try it to get the answer. Okay, now, this one, cube root of x squared, square root of x, I will write it x to the power half. So I change it to rational powers. And then when I multiply here, x squared, x power half, I have the same base, you see that? X squared times x power half. So I can add the powers. I think you remember from algebra. If you have same base here, x and x, you can add the powers. So 2 plus half, 5 over 2. And then I can take this cube root as the power 1 over 3. Then I multiply the powers. 5 over 2 times 1 over 3. So 1 times 5 is 5. 3 times 2 is 6. X to the power 5 over 6. So this is 6th root of x power 5. That's the answer for this. Not 6th root of x cubed. 6th root of x to the power 5. Now we go, this is a practice number 1 for you to try yourself. Try to do it, practice number 1. Try to do practice number 2. Multiply here, I put here nice 3 radicals, small radicals, square root of 3, square root of 2, square root of 5. Multiply all this and simplify the answer. It will be one simple number. And then take practice number 3. I have cube root of square root of x times square root plus 4th root of x. Also nice to try. The answer is there in this slide. You can see practice number 1, the answer. Practice number 2, the answer. Practice number 3, the final answer. Thank you for watching. I hope you get some benefit from this. And also you can try the other MC errors, part 2, part 3, and part 4. Thank you for watching.